All right, so let's get started, everybody. Welcome to the session on Elastic Database Pools. My name is Thorsten Grabs. I'm a program manager on the Azure SQL database team. And what I want to do in the session today is basically give you more details on Elastic Database Pools. What are the specific workload characteristics that you should be looking for? What are typical scenarios where you would want to use the Elastic Database Pools? And then compare it to the currently existing single database offering that we have for Azure DB, and basically contrast the different use cases, the different characteristics of the workloads. When would you use one? When would you use the other? To establish some context for us, I just want to give you some quick background on where is this happening. So obviously we're talking about Azure, we're talking about cloud. Azure SQL DB is a fully managed database as a service offering in the Microsoft Cloud. One of the key objectives for us with that service offering is to make it easy to use, easy to set up, easy to configure, so that you can quickly focus on the business logic, your application on top of the database. One particular area that I think differentiates us quite a bit is the ease of setting up high availability, disaster recovery, business continuity. That's not at the core of this talk today, but that's something that we care about a lot, and I think that differentiates it also from other offerings, also our own offerings for SQL Server in VMs that you can run in VMs in Azure. Now, one of the particular topics that I think is becoming attractive, and it's new in this conference and due to the announcements that we made at Build last week, is the particular focus around software as a service and how we're making it easier with these announcements to build software as a service applications in the cloud. So far, our offerings have been most attractive, I would say, for enterprise applications, particularly when you had predictable performance. And based on the predictable performance, you could get a very predictable pricing and attractive pricing as well. Now, with Elastic Database Pools, it becomes much easier to create databases on the fly and to accommodate fluctuating workloads that have less predictable resource requirements, capacity requirements. I already mentioned availability. We provide 4 nines out of the box, and in addition, on top of that, we can also provide you geographic disaster recovery through geo-replication and also through restore, backup and restore into different geographically distributed data centers for data protection. One other area where we've made significant advances over the last year is being compatible with our on-premise SQL Server offering. With the new SQL DB v12 update, at the database level, we're almost fully compatible with what you can do with SQL Server on-premise. And I'm mentioning specifically the database context. If you think about what you do on-premise, you have the database, but the database is hosted within an instance within the server. And the server gives you one level of manageability, and then there's a database that gives you another level of manageability. So at the database level, you will find that it's becoming more and more easy to basically lift and shift an application from on-premise and bring it over into the cloud. So to establish some more context, how are we all basically selling this to our customers? There are basically 3 different tiers, 3 different performance levels that you can get on Azure SQL DB. And let's start with the differences. The main differences are around storage capacity and the performance and the resources that you get. What we call the basic tier is targeted towards light workloads, and then going from basic over standard to premium, you're getting more and more resources for your workload, and you should see performance incrementally improve, response times, throughput getting better as you move a database from basic to standard to premium. All of these you can do in an elastic fashion, so that means you can basically come in at any of these service tiers, and as your workload changes over time, you can also adjust the service tier for your database. And you can do that without causing an outage for your application. So it's an online operation. If I have an existing database in standard tier, let's say S3, and I want to bring it up into the premium tier to a P1, let's say, that's an online operation. It may take a couple of minutes, but your database stays fully available during that time. Now, the other aspect that I already mentioned was around compatibility, where we made lots of progress. The programming surface, the feature set, we are trying to keep that as much as possible in sync between the different service tiers that you see on this slide here. There are some more resource-intensive features that at this point currently are limited to some of the higher tiers, but we're working on making all of our features available across all of the different tiers. So speaking of these different tiers, what does that mean when we talk about performance? And in order to do that, I'd like to introduce you to the concept of a DTU, a database throughput unit, which is basically the measure of resources that you get and that you acquire and that you work with when provisioning databases in Azure SQL DB. And the database throughput unit, the DTU, is basically a measure of the compute resources that you get, the amount of writes and reads that you can do, and the amount of memory that you get. And basically that bounding box, that amount of resources is guaranteed to be available for you when you buy a certain service tier database. So for, let's say, an S0, you get a certain amount of compute, writes, reads, memory, and you can use it. Now, if you go to a higher service tier, the number of DTUs will increase, and the amount of resources that you get in all these 4 different dimensions will increase accordingly. So if you go from, let's say, 10 DTUs to 20 DTUs, all the resources within that bounding box will double because you doubled the number of DTUs for your database. And now, assuming that you're probably not using all of these different resources at the same level, what really counts and what we are measuring is the maximum amount of DTUs, the maximum amount of a single resource in a single dimension that you consume. So that's the picture that you see here on the right-hand side. So you see that your reads, you're doing more reads than writes, CPU, or memory in terms of percentages. And if you get closer to 100%, and at some point you hit the 100% in one of those dimensions, we would start throttling you because you're at a point where you would exceed your resource allocation. So why are we doing that? Why are we providing that abstraction? It gives us a way to give you a measure of resources and performance if you write your application accordingly that abstracts from the underlying physical hardware. And we're constantly bringing new hardware generations into SQL DB, and we're basically benchmarking all of these new hardware, to make sure you're getting the same DTUs, the same resource experience for a database, no matter what hardware you're running it on. So here is a picture that gives you a sense of what the different DTUs and scale factors are. So you can basically start with our smallest service tier, the basic tier, and you get 5 DTUs. And you can scale this up as your demands, your workload, your capacity needs increase. You go through the standard tier all the way up to 100 DTUs. And with 100 DTUs, as I mentioned, you get 10 times more resources on the S3 than you get on the S0. And then you go further up, if you need to, into the premium tier, up to our largest one, which is currently the P3, which gives you 1,000 DTUs. We're working on making even higher scale factors available in the premium bucket. So those are coming up as well. And if your workload characteristics change at some point, you can obviously also go back to smaller service tiers. And all of that, as I mentioned previously, is an online operation. The billing model that we're using is hourly. So if you're using a database in a given hour in a particular service tier. We will bill you for that, which makes it quite attractive to spin up databases on demand or to change service tiers on demand. Because, I mean, if you go back to a smaller service tier, you can already start saving money in the next hour. Okay. So now let's look at a couple of databases, and let's assume we have an application running, and different numbers of users are logged into the application, and they're generating a workload. And you can see that to the right, there are more people using it. But suddenly something happens to the S0 here. For instance, it's an application that just went viral, and lots of users started using it. So the S0 tier couldn't accommodate that. So let's bring the Elastic Database Pool into the picture. What the pool does, it allows an individual database to flexibly stretch across the whole service tier, in this case, the standard tier, depending on the resource demand of the application. And here the application basically illustrates as the workload fluctuates and different numbers of users are using different databases in different ways, the resource consumption of the databases flexibly goes up and down. And you could imagine basically dynamically adjusting the service tiers for a small number of databases, but now imagine doing this for tens or even hundreds of databases. That would be quite cumbersome. You would need to basically write a policy or implement a program that does that for you. So with these pools, we are making it much, much easier to manage large sets of databases and giving them the ability to dynamically burst if there's a peak demand from the workload, and then dynamically go back into, let's say, idle or less utilized state. And the way that we're doing this is by basically giving you an overarching resource allocation for the database pool, and then the databases that you put into the pool will share that resource allocation. And the reason why I spend time introducing that database throughput unit to you is that the overall capacity allocation for the pool is also expressed in terms of DTUs. Now, for which scenarios is that appealing? So the sweet spot for the more traditional service tiers, the places where you would use a basic, a standard, or a premium tier for your database, is when you have a well-known, well-understood workload. It's very predictable, and it's very consistent over time. In particular, you want to use that for workloads where idle periods are either small or they don't exist. And then the single database allocation is the best approach for you, both in terms of a performance perspective as well as from a cost perspective. Now, the risk that you're running always when you're using single databases is you might run into cases where you over-provision because you do have peaks and you want to accommodate these the resource and workload peaks. And that if that happens more and more, then you're going into workload characteristics where using an Elastic Database Pool is becoming attractive. Now, let's switch to the other end of the range, and let's talk a little bit about what's the typical workload characteristic for an application that would want to use an Elastic Database Pool. So the first one is from a manageability perspective. If you have lots of databases, and it's a pain to keep track of them, it's a pain to manage the service tiers for them, that already indicates that a pool might be attractive for you. The other pattern that you should watch out for is, do we have periods with lots of activity, so spikes, bursts in the utilization that are followed by long periods of inactivity? And then this is the second aspect to watch out for. The third one is, do these spikes and long periods of inactivity, do they happen at different times for different databases? So you want the databases not to have these bursts or to have these peaks all at the same moment. You want these to happen in a somewhat randomly distributed fashion. And that basically paints a picture for you of somewhat unpredictable workload for the individual databases that is varying over time. And if you look at the slide here, I'm trying to illustrate this with these little curves. So you see that normally on average the databases have a fairly low utilization, but you see all of them spike at some point in time. And you want to have the ability to accommodate these spikes, obviously. And that really is the ideal picture for a database pool, because you basically define the pool capacity to accommodate the largest spike that you observe over a large period of time, and then provision capacity for the aggregate utilization of all of the databases. And I'll have examples that illustrate this in a little bit more visual fashion, actually on the next slide. So let's talk about this and in a little bit more detail. So let's start with a picture again here. So, oops, wrong button. So here you see the individual utilization of a single database, and you see the spike that it has. And you also see that it is within certain bounds, so you can express the utilization pattern by establishing a minimum. Some of the databases may actually go completely idle, so the utilization drops down to 0. But then they also spike. Now, if you basically plot this curve here, the blue one, for each database that you have in your application, and the spikes are happening all at different times, you may end up with an aggregate utilization across all of the databases that looks like the curve up here. Basically a somewhat squiggly line, but fairly steady utilization over time. And that's really the pattern that we are looking for that makes the elastic pools attractive. And once you spot these patterns, and there are tools that we give you to help you with that determination, once you spot these patterns, then basically the way that you provision the pool is you say, here is an amount of DTUs that I want to allocate to the pool, and that is then shared across all of the databases that you put into the pool. The individual databases, I think I mentioned this earlier already, then can basically stretch through the whole spectrum of the service tier. So they can start out at S0, but then go all the way up, spike up to an S3 if they happen to get one of those bursts. Now, besides the resource allocation in terms of DTUs, there's also a storage constraint that is a function of the DTU number that you put on the pool as well. And we'll see that when we provision a pool from the portal. Now, the pricing is somewhat similar to the pricing for the regular databases. So you pay a certain amount for the number of DTUs that you have put into the pool, so there's a price per DTU. The other dimension in the pricing is the number of databases, so there is a dollar figure attached to each database that you put into the pool as well. Okay. So here's where we currently are in terms of the elastic pools. We announced elastic pools last week at Build, and the only pools that we currently support are pools for standard tier databases, so for S0, 1, 2, and 3. And the other pools are working in progress, but we are committed to making pools available for both the premium tier as well as for the basic tier. So let's look into some of the characteristics of the pool right now. Right now, it's a temporary limitation. You can put up to 100 databases into a single pool. We want to increase that number significantly, but we are in preview right now, and that's the place where we start. But you should expect to see that number go up to several hundreds, thousands, or even 10,000 databases that you can put into a single pool. I already mentioned that there's a relationship between the number of DTUs that you provision for a pool and the overall storage capacity for the pool. And right now, that number is per DTU, you get 1 gigabyte of storage, and then that gives you the overall amount of storage that's shared across all databases that you have in the pool. Also, there are only certain capacity configurations available right now that you can choose from for your pool. We are starting out with 200, 400, 800, and 1200 DTUs. Those are the pool capacity sizes that you can choose from. Again, that's something that we will probably adjust both at the low end, so probably we will come out with a pool sizing of 100 DTUs pretty soon. And then also you can think of getting larger pool sizes above the 1200. That's also work in progress. You can, yeah. So the question was, can you change that size? So once you've defined your pool and you put all the databases in it, you can monitor how the resources are being consumed. And if you see that you're getting close to the capacity limits that you have provisioned for the pool, you can increase that at any point in time. And similar to the service tier changes for individual databases, this is also an online operation, so your databases will stay available while you are increasing or decreasing the capacity for your pool. The pricing for us right now is if you put a database in the pool, you pay about $2.50 per month for it. That's the pricing that we anticipate when we make pools generally available. Today, the price is half of that because we are in preview, so we're getting that 50% discount on it. The same statement is true for the price that you pay for a DTU that you provision for a pool. That's for GA, we're expecting this to be $4.50 per month again. And right now it's 50% of that, again, because we are in preview. Okay, other than that, besides the DTU numbers and the ability to basically stretch a database through the whole spectrum from S0 to S3, there's also another performance metric that may be interesting to you. So for instance, the amount of sessions that you can open against the database, the number of worker threads that you can have in the database, those are also different for the different scale factors in the standard tier. So S0, for instance, will allow you to come in with a much smaller number of sessions as compared to an S3. If you put a database into a pool, these metrics also become flexible. So a database that's heavily utilized and it is in a pool may start out at the S0 level in terms of sessions, but if more users want to connect to it, it can go all the way up to an S3. So it's not just the DTU amount that can be consumed by individual databases during a spike or a burst. It's also the number of sessions and worker threads that are related to the other factors that are related to capacity that follow a similar pattern. Okay. So let's take a look at some typical use cases. Here I'm just basically plotting charts for different numbers of databases and their utilization pattern over time. So the first one is just a simple database that has like 4 or 5 spikes over time. And as I start basically adding databases into the mix, these spikes happen at different points in time. So this takes us to this chart down here. And that might be a very typical situation. If you are a SaaS provider and you're new to the business, you start out with a very, very small number of databases. You're probably somewhere here between, let's say, 1 or 4. And as your business grows and you start adding customers of yours or you start adding tenants, it becomes very easy for you to basically do that in a database by database fashion. So as you onboard a new tenant into your application, you just create a new database for that tenant and make sure that the application routes transactions and requests to that new database that you created. And that's exactly the pattern that we see at work with lots of our ISVs that are becoming SaaS providers right now. Some of them have thousands or more than 10,000 databases in Azure SQL DB. Our large-scale customers create somewhere around 60,000 databases per week. And they create them, and many of them are being dropped within a few days. So it's a very flexible, very dynamic pattern. And in many of these cases, the workloads have these characteristics that there are periods where the database is used and maybe used heavily, but then there are long periods of idle time. There might be even some tenants in your SaaS application that only log in once a month, and for the rest of the time, for the rest of the month, the application in the database is completely idle for that tenant. If you provisioned a single database for that, you would probably go somewhere around the spikes for the capacity allocation. So that's exactly the situation where you end up over-provisioning, and you're basically paying for the guaranteed capacity for all of the idle time as well. And as you get into the tens, hundreds, or even thousands of databases, that becomes very, very costly. You're basically paying for resources that you're not utilizing in the aggregate. So, and that then takes us really to a place where you start having tens and maybe even hundreds of databases. And if you overlay the utilization curves for these different databases, you get a picture that looks very much like the one that I have on the right here for 20 databases. Now, if you take a look at the aggregate DTU utilization in that 20 databases picture, you can probably see that the spikes go up to 90 DTUs at most. Now, if you basically plot the aggregate DTU consumption, because the spikes happen at different points in time, your overall DTU utilization is probably somewhere around 100, maybe 150. But it's never like 20 databases at 100 DTUs, which would take you up to 2,000 DTUs, which would be the situation if you provision individually for peak capacity. So the aggregate utilization that you need to accommodate is way, way lower than the sum of peak utilization capacities. And that's really the economic problem that you run into when you manage a workload, a database workload, with these many databases at the individual database level. Because you would basically, if you provision for 100 DTUs to accommodate the spikes, you would provision 20 S3s. Each S3 is about $150 per month. So you end up paying $3,000 per month if you followed that model. So that's, as I mentioned, you're paying for resources that you are guaranteed to have, but that you're actually not utilizing because your customer workload is such that these spikes are followed by long periods of idle time, right? So, and this is really the economic argument where it starts making sense for you to go to the Elastic database pools instead. I'm using the same pictures here for 1 and 4 databases on the left, the same spikes, but here now I'm plotting basically the aggregate utilization of the 20 databases with all of their spikes, and that's this black curve that you see here that's basically at the max aggregate utilization. And as I mentioned, that doesn't take us way beyond 100 DTUs for all of the 20 databases. And that puts us in a place where we can put all of these 20 databases into an Elastic database pool. We can configure that pool right now to be at 200 DTUs, and all of the databases with all of their spikes would comfortably fit into that overall resource allocation for that pool. And if you basically follow that model and you basically look into it and plot the different cost curves, you end up with this chart and the two curves down here that I find very interesting. Basically, as you add databases into the pool and the individual databases are provisioned for peak capacity, you're basically on that trajectory where each and every database that you add into the mix just increases the overall cost. So you have this linear cost function that keeps increasing as you add new customers, new tenants into your SaaS application. With the pool, the cost curve is actually flat. You can add databases into the pool and do that as long as the aggregate utilization is not above the pool's configuration, the DTU configuration. And for the 20 databases, this perfectly works. So in this example. So the curve is flat. If at some point you get, let's say to 40, 50, 100, or 1,000 databases, probably the pool size down here won't fit anymore. But then you have a step function that basically takes you to the next level of pools, where you basically go from, let's say, 200 DTUs for the overall pool allocation to 400 DTUs. And then you're on that, once you basically went through that step function, you're on another flat curve that carries you over to the right, to a larger number of databases. Question in the back, please.
Is that step function automatic, or do you have to manually?
So the question was, is that step function basically the adjustment in the overall resource allocation for the pool? Is that automatic? Right now, it is not. So it is something that you can monitor and you can set alarms on, but we want you to basically go into the portal or to go into your PowerShell and then adjust the configuration for it. You could think about putting a policy around it, basically trapping the alarm or watching the telemetry coming back and then reacting automatically to it. But since you're changing cost, there's a price attached to it. We would like to have you in the loop for doing that, at least for now. If more people want it, certainly I think we can put policies on top of it. Okay. So let's talk a little bit about the user experience. So we basically went through the economic arguments. When is your workload shaped in a way so that pools become attractive for you? And then what are the economies and the cost behind it? Let's talk a little bit about also the manageability of the pool and the basic use cases for putting databases into the pool. So right now, a pool is limited to a single server. So a logical server in Azure SQL DB is a logical container for a number of databases. And you use the server, for instance, to define logins, users' password. The firewall is configured at that level as well. If you go into a logical server in Azure DB, I'll show that in the demo in just a minute, you can define a pool and decide which of the databases you want to bring into a pool. A logical server can also have multiple pools, which might be attractive for folks that think about different customer segments. So if you're building a SaaS application where you want to differentiate between your, let's say, your free tier customers versus your gold star customers, you could put your gold star customers into a premium pool once we have that premium pool available and keep your basic tier customers in a standard pool. That would be an attractive situation where you might want to consider creating two pools, one for premium and one for standard, within the same logical server, just to give an example here. The experience for setting performance goals is quite straightforward. And I'll walk you through the wizard in the demo and explain a little bit how the wizard helps you determining which databases to put into the pool and how to set the overall resources and how to define min and max DTU boundaries for the individual databases. Now, the other aspect is I can dynamically create databases in a pool whenever I need to. So again, thinking of that SaaS application, as soon as I want to onboard a new tenant, I can create a new database for that tenant in the pool. Also, I can dynamically take databases out of a pool. So for instance, if I'm building a ticket selling application and I know that Madonna is coming to town to a particular venue that I'm hosting in a database in a pool, I know that this database will be very, very busy during the first few hours or days when the tickets for Madonna are sold and all the fans that are coming in. In order to accommodate that, I could take that database out of the pool, put it into a separate premium database, or configure the database to be in the premium tier so that it can accommodate that huge load while the tickets for Madonna are being sold. Once that kind of burst of activity is over after a couple of days, I can bring that database back into my pool. And that, as I mentioned before, is an online operation. Your application will continue to run and be able to connect to that database. Okay. Let's get a little bit closer towards actually creating pools and the experience for it. So there are a couple of interesting tools that we provide you, and I'll show you those in the portal in just a second. Those are screenshots of it. We run machine learning behind the scenes that is basically analyzing, trawling through all the utilization, all the telemetry that we get from your servers and databases in Azure SQL DB. And the machine learning algorithms are looking for exactly these patterns that we just talked about for the last 20 minutes. So the utilization where you have a number of spikes, but lots of idle activity as well. And then are these spikes in different places for different databases in the same logical server? So that's something that's fairly straightforward to analyze with machine learning. And based on that, we are recommending to you the databases in a server that we think are good candidates to be brought into an Elastic database pool. You can choose to go with our recommendation, but you can obviously adjust the set of databases that you want to bring into a pool and then actually create the pool. The experience for managing an existing pool is very, very similar. So we show you the resource utilization all up for all the databases in the pool. That's the place where you would define your alarms to find out whether you're getting close to the capacity limit of the pool. And then you can adjust the settings, the capacity settings for the pool at any point in time. So why don't we look at that in the Azure portal? I think I'm on 7 here. All right, I have been talking for too long. My session expired. Sorry about that. I agree. All right. Oh, no. Damn it. This is another good security feature, but if you're on stage, it's not that good, because I'm going to get a call in just a second. And I hope I have reception down in here.
There's an app you can download.
I know, but the app gave me grief, so. There we go. Two-factor authentication at work at Ignite. All right, so here we are in the Azure portal, and let's start with a server that I have here that I've put onto basically my my homepage in the portal, and it lives somewhere in central US. It has 30 databases in it. Let's look at all of the different databases that I have here. And the first observation, which is quite typical for these cases where pools are attractive, is that all of these databases have different performance levels. So there's a mix of S0s, S1s, S2s, S3s, and that is really driven by the utilization that I'm observing as, let's say, the DevOps person or the DBA. As these databases are being used, I go in there and I adjust the performance levels. And maybe for 30 databases, that's still manageable. But at some point, if I go beyond that, I would either automate that or bring my databases into a pool. So let's look at some other aspects. If I open up a single database here, let's see whether I find the right ones. You also see the other interesting pattern that we have been talking about all the time. You see some interesting spikes down here where somebody's obviously doing work in the database, and these spikes are followed by long periods of inactivity. So you can do that yourself, but if you have a number of databases sitting in Azure SQL DB, go and take a look at what's the resource utilization, and do you find these patterns where some of those databases spike and then go silent again. Let's look at a different one, just the next one down in the list. And we should see a very similar pattern with one difference, though, that these spikes should occur at different points in time. So then if we basically overlay all of the utilization curves from the 30 databases that I have in the pool, they all will have spikes at different places, so we'll have a fairly flat line. In aggregate, they don't go way beyond the maximum capacity for a single database. So from that initial kind of sniff test, that looks like a bunch of good databases to put into a pool. Now, basically the functionality that we added into the portal is this button up here that allows you to add databases into a pool. And then there's a couple of steps that you need to go through. Right now, the only pricing tier that we support is standard, but basic and premium will come up soon as well. The other aspect, as I mentioned, is really which databases do I want to bring into that pool? And I mentioned the machine learning functionality that we run behind the scenes. I mentioned that earlier. That's at work exactly here, at this place that we're looking at. And in particular, that recommendation column on the very far right is where we show the result of the analysis that we have done through machine learning. In addition to that, we are also showing you other metrics that are important. For instance, what are the spikes, what are the peaks in terms of DTUs that we have observed during the observation time for individual databases? That's the third column from the left. The next one then is the average DTU. Again, same period of time, what have you observed? And typically what you're, again, interested in is, do I see large differences between the max versus the average? And that is, again, an indication of that pattern at work where you have occasional spikes, but overall the database is not used very heavily. And you can see that this is the case for many of the databases that I show here. The peaks are way, way larger than the average utilization that we see over time. And that's just one of the reasons why all of these databases now in this case end up being recommended for participating in the pool. So let me go over that recommendation here and just select all of those databases. All right, and the next place, once we have chosen the databases, is how do we want to define and provision capacity for the overall pool? And the key thing to think about there first is what's the aggregate utilization for all of the databases in the pool? And that's the first chart that we show you here. It's basically that blue line that we plot for the last couple of weeks where we have observed utilization. And now in the aggregate across all of the databases that you have chosen, what are the spikes, the peaks, and the valleys for the aggregate DTU utilization? And that helps you to define what's the amount of DTUs that I want to allocate for this pool. And as you can see right now, here you have the 4 different options, 400, 800, 1200, and the 200 DTUs. Based on the data that I have here for these 30 databases, 200 DTUs would be enough. None of the spikes that we see goes above the 200 DTU line. So we can go with that. So that's kind of the first aspect. What's the overall capacity that I want to allocate in terms of DTUs to my pool? And then the storage size for the pool is an implication of that. So if you chose 200 DTUs here, you'll get 200 gigabytes as overall storage size for the pool. And if you increase that or change that, they go in tandem. So 400 DTUs will get you 400 gigabytes. And the storage size is the orange line here. So that is also fits well into the current pool configuration. Now, the second part then is thinking about what are the individual capacity caps and boundaries that I want to establish for individual databases that live inside the pool. And that basically tells us, or tells the pool that manages the databases for you, how far do I want to allow individual databases to spike up and basically draw resources from the overall resource allocation that I've made for the pool. That's the maximum amount of DTUs that you can configure individually for databases. The second aspect is, do I want to set aside minimum capacity for each database in the pool as well, so that I'm sure that at any given point in time, each database has a certain amount of resources to work with. And that's the second one. So the first one that I mentioned, which is basically the level to which we allow databases to spike up, is the DTU max. And in order to help you set the DTU max, we're showing you this histogram that basically shows you in an ordered way the different databases that you have selected for your pool. And the first one that's shown in the histogram is the one that had the largest spike in the observation period. And you see here, this database spiked up to about 70 DTUs at the max, but the average is down here, this little green area. So it hasn't been utilized a lot in the average, but it had a few very large spikes. So in order to accommodate these spikes for the first few databases that I have here in the histogram, we would need to set the DTU max to 100. We could also set it to 50, and then the chart shows you what happens. It basically would cap the databases, their spikes, at the 50 DTU level, and that would cause throttling for the application that's using those databases. The application wouldn't necessarily fail, but we would queue the requests for you. They would need to wait until resources are available again for processing. That might be fine for certain applications that are not time sensitive, not time critical. You can accommodate some wait time, let's say for batch jobs that you run or overnight reporting jobs that you just need the next morning. For those situations, it might actually be an appropriate choice to set it to a lower DTU max and have some throttling, some capping happening for individual databases. So that's the maximum, basically that controls the level to which individual databases can spike in your pool. The other one is the DTU minimum here. And let's say I'm putting this to a minimum of 10. That would basically put us in a position where if one of the databases during a spike becomes a noisy neighbor for the rest of the databases in the pool, we would have a guarantee that each database still has 10 DTUs to work with. But the minimum also means that this is available for all the databases in the pool at all times. So one implication of that then is, if I do this here with the 30 databases that I have selected, that I can no longer fit all of the 30 databases into my pool because each database gets 10 DTUs at a minimum. Multiplied by 30, I would end up somewhere around 300 DTUs if I do the math right. So in order to bring all 30 databases back into the pool, and we show you a little warning up here to help you with that, we would need to go to a larger overall pool allocation, and then all of the databases would, again, fit. And if I do that, I could actually fit now 40 databases into the pool with the minimum setting that I've just configured. Now, so that's a reason, or protecting against noisy neighbors that draw resources from the pool is one of the use cases for setting the minimum to something different than 0. However, there are also use cases where you want this number to be exactly 0. And the chart, again, helps with this here. So the histogram shows that we have a fairly long tail with databases that are, even on the average, not utilized a lot. So if you think about a multi-tenant SaaS application, you might have a lot of customers that just come in once a month, but other than that are dormant. And the databases for those customers would probably show exactly that pattern, that they are that there's very little utilization, a very, very long tail with lots of very cold databases in it. And for those cold databases, it might be very attractive for you to just set the minimum to 0, and then those databases are truly cold when they're idle, when they're not used. They're not going to draw any DTUs from the overall capacity allocation unless someone logs into the database and starts doing work with it. So that is a situation where you actually want the DTU minimum to be 0 if you have lots and lots of these idle, cold databases. All right, so we could now, basically with these settings, create the pool. Sorry, I want to show you one more aspect. Let me just go through the steps again. Let's go through the steps again. So if we went with these settings for these 30 databases, you can now take a look at the pricing as well. you see we have 30 databases. The preview price is half of $2.50, so we are at 1.25 here. That gives you the database cost for the pool. And then we have the capacity price, which is $2.25 for 200 DTUs. So that gets us to an overall monthly price for the pool of about roughly just below $500. If you compare this to the price we would have to pay for the individual databases that we had allocated and that we were managing individually, basically those guys that you see over here, those right now cost me between $2,000 and $2,500 a month. So putting these databases into a pool is quite attractive for me right now from a cost perspective, in particular because we have the preview pricing. I'm basically paying a quarter of what I would have to pay for the original databases. If the preview pricing goes away, it's still quite a significant benefit, so it's only about half of the price that I would pay for the individual databases. Okay. So that is the configuration and the setup for a pool. Let's take a quick look also at basically managing an existing pool. And here I have pre-created a pool. Creating the pool may take some time because even if the databases exist, when you put them into a pool, we may move around some of the databases between different pieces of physical hardware in our data center. And so that's depending on the data sizes that you have in your databases, that's a long-running operation. Again, as I mentioned a couple of times, the databases are available, but you will see basically a provisioning process running for you for a couple of minutes, maybe an hour or so, until all of the databases have been brought into the right place. So here I have an existing pool, and I just want to show you the monitoring experience. So here you can look at the amount of storage and how the storage is being used. So we're just below 60%. I'm actually not putting any work on, no workload running on this pool as well. You can look at the individual databases and how they are being utilized. And you can make adjustments at any point in time by basically saying configure pool. And you're going into exactly the same set of dialogues and charts that we just looked at for creating a pool. And you can make adjustments here to the overall DTU number, as well as to the mins and max for the individual databases. Okay. So that was basically a quick walkthrough in terms of the portal, how to define a pool, how to inspect the different metrics and charts and the machine learning outcome that we show to you to make it easy to configure a pool for you. There are also other ways to do that. So if you're not one of the kind of UI persons or you want to automate that in some way, there are PowerShell commandlets for pretty much everything around pools that you can use to do that in an automated fashion, in a scripted fashion if you want. So here are just a few examples that I wanted to show you just to illustrate that all of these things that we just saw in the Azure portal are available through PowerShell as well. So the first one is you can create a new Elastic pool. You give it a resource name. You tell us which server it is on. What's the name of the pool. You tell us whether it's going to be a standard, premium, or basic pool. And then you have the configuration parameters around the overall DTUs for the pool, plus the min and the max boundaries for the individual databases. A very important one is creating new databases within the pool once you have created it. And that's the second one. Pretty straightforward, very similar to the regular PowerShell commandlet to create a new database in Azure SQL DB. So that's where basically a new database gets bootstrapped and created within the pool. You also can take an existing database that currently lives outside the pool and move it over into a pool that you have defined. That's the third PowerShell commandlet that you see here. And then there, obviously, the reverse. You can take a database and remove it from a pool. That's the fourth one that I have here. And then the last commandlet is around adjusting the performance settings and the resource allocation for an existing pool. So those are probably the most important ones from a PowerShell perspective that you would run into. Now, what are some of the things that are on our radar and that are currently work in progress for us? Probably the most obvious one is, hey, today I only have standard pools. What about basic and premium pools? That's stuff that the team is working on. And the other area is to bump up that limit that we currently have, that you can only put 100 databases into a single pool. We want to give you the ability to bump that number up, to increase that dramatically. And then also making the configuration choices more flexible. Right now we only have these 4 different capacity levels for pools, 200, 400, 800, and 1200. We want to give you different options there, smaller and larger sizes that you can go with, but maybe also a finer granularity where you can pick, for instance, something like 500, which is not available right now because it's not one of the predefined sizes. Then now you've seen the PowerShell commandlets for basically doing operations with databases and pools. Some folks are interested to do that at the T-SQL level as well. Right now, this is only available through PowerShell. There's work in progress to also start supporting that through T-SQL. Now, some of you might be running the... go ahead, yes?
Do you have any ETA for the T-SQL?
Nothing that I can share at this point. But give me your card after the session, and we can get a conversation started with the team. The last point then is some of you might be running existing databases in the older version of SQLDB, the V11 version, and then how can we make it easy for you guys to basically bring those databases from V11 to V12 and directly into a pool. Here are a couple of places for you to find additional information. If you want to read up on some more details, go check out the slides. They should be online. And then follow those links. And here's a summary slide. So if you look at Azure SQL DB and the last hour that we spent on database pools, think about Azure SQL DB as a global database as a service in the cloud. So we have regions across the globe, and you can basically place your data wherever you want or whatever your compliance regulations are. The existing offerings for databases work very well for predictable workloads, and we talked about the cases where you have a workload pattern that's best suited for what we already had in SQLDB. Now with Elastic Database Pools, it also becomes much, much easier to accommodate large numbers of databases where individual databases have fairly unpredictable load characteristics. And you can now put these databases into a pool, and there are 2 benefits to that I want you to take away. The first one is it becomes much, much easier to manage capacity for these databases once you bring them into a pool. And the other one is that you're likely going to see cost improvements as well by sharing the capacity for the pool. Besides that, we're also working on making development, DevOps, and manageability easier for a group of databases, particularly a group of databases that you bring into a pool. So we are working on a feature that's called Elastic Database Query that allows you to query across a set of databases from a single endpoint, from a single SQL Server connection. And I'll show that in a session later today. The session is called Elastic Scale for Azure DB. It's at 5 o'clock today. The same is also true for manageability operations. So think about rebuilding indexes across, let's say, tens or hundreds of databases, or updating stats for that many databases. In order to help you with that, we offer a new capability on top of pools that's called Elastic Database Jobs. And you can put in a T-SQL script and then basically farm it out, roll it out across all of the databases in the pool in a reliable fashion. If that's something that's interesting to you, come to the session in the afternoon as well, and we'll talk a little bit more about it then. Okay, I've been told to include this slide into the deck, and you probably know more about it than I do. I think what you guys need is this session code, the TZDL, and I'll leave that slide up there. And with that, that's all the content that I wanted to share with you. Please, let's open the floor for questions. If you don't mind, if you could use the mics, it would make it easier for the folks that are doing the recording.
Hello. This is pitched to SaaS. I can see this working really well in a kind of enterprise environment where you've got, like small databases in a heavily consolidated server. Like the company I'm working at, which is a bank, each database gets a virtual machine at the moment, which is quite expensive and wasteful and management cost. Could you see this being used for that scenario where you put a bunch of database into a pool that's, say, owned by a business unit and it's charged that way?
Yeah, I think really the aspect that you should look for is really is your workload pattern behaving in a way that makes it attractive for pools. Yeah. And if that's the case, then just go for it, no matter whether you are an enterprise customer or whether you are a SaaS provider. It really doesn't matter. What the key aspect is, what's your workload like? We just happened to see many of these workloads with the SaaS customers and partners that we have been working with. Enterprise applications, just from our experience, tended to be a little bit more predictable in terms of their workload characteristics. But if yours is different, go for it. Other questions?
So this sort of seems like a no-brainer for people that are currently on SQL database. But as a SaaS vendor who's currently using their own managed SQL Server instances, the question becomes one of price. With our existing databases and using our own managed servers, we get an economy of scale as we add number of databases. Whereas this seems to have more of a flat pricing model, meaning that I add my 999th database, it's the same cost as adding my first database practically. Yeah. So I'm wondering if you're thinking about trying to address that sort of disparity for those of us that are managing our own SQL Server instances because of that economy of scale that we're receiving.
So are you concerned about, so it's not 100% true that each incremental database is completely free of cost. So there are two parts to the cost of a pool. One is the processing capacity. The other is the number of databases that you have in the pool, right? So that's.
But from that standpoint, it's I don't get for 500 databases, you divide the cost by 500, it's exactly the same if the cost per database is X. Whereas if there's no discount that I get, because for me, I get a discount as I add my. The price drops as I add more databases to that single instance because I'm amortizing.
So when you say single instance, are you thinking about on-premise SQL Server or
even on an IaaS
on an
installation VM? I mean, I can adjust the numbers as I go up, but there's some. I'm receiving an economy of scale by managing the databases myself on that instance.
And that's maybe fine because you're biting the bullet in so many other aspects. Like, for instance, if you want to get to 4 nines of availability, you have to really manage that set of VMs very closely, very tightly. You have to configure always on, which is not easy. And you're getting this out of the box with SQL DB.
But a standard VM has got 4 nines of availability, doesn't it?
A single VM, no. There's no availability SLA at all for a single VM in Azure.
But I get, on the tests that I've done, I get better than 4 nines.
Then you might be lucky. I doubt that because about twice a month the Patch Tuesday monkey goes to our data centers as well. So I'm not sure. I'm convinced that I would get the same number. So. In general, the statement that Azure makes for VMs is you need to provision at least 2 VMs in an availability set, and then you get a number which is 99, 3.5 nines, which is lower than what we give you out of the box for a single database.
Okay. No, I understand that. I understand what happens. It's just not. I haven't seen that in my own experience. Okay, thanks.
Got a few more. Is that?
Yeah. Want to use the mic?
Yeah. So I'll just get my head down. You had the machine learning stats. Is there any way of resetting that or adjusting the period of the machine learning, you know, where it gave the recommendation of yes, no? You know, because I was thinking you might have a sort of uncharacteristic workload for a database that happens for some reason that skews the stats. So, you know, say you were doing some testing or something and you wanted to kind of just reset and say, oh, that's a load of rubbish.
We don't expose a knob to reset this at this point, but you don't have to go with a recommendation that comes out of machine learning. If you walk into, let me just switch over. If you walk into the configure pool blade, you can pick individual databases and just put them into a pool. Let me show you that. So here it just happens to be all recommended, but you have these check marks to the left, and you can just basically toggle them and say, hey, I don't want these guys in the pool. No, why doesn't this? There you go. All right.
One more.
Go for it. Yeah.
So what happens when you get throttled? When you hit the ceiling, is it just, I assume, your queries will go slower? It's not.
So
it's not like you get disconnected like you used to in the old days with SQL Azure, right? Or something.
Well, there are two cases. One is you might just end up in a queue, and basically your request is stuck there, and you wait for the request to come through. Yeah. If the queue fills up and we don't have any space in the queue anymore, then you actually may get an exception on the connection that says to you, hey, you just got throttled, and retry the connection after some time. Yeah. That's the typical transient failure situation you need to be prepared for. And you can use exponential backoff techniques. You can use the transient fault handling libraries to do that.
Can you query, I guess my follow-on question is, can you query via REST or PowerShell when that happened against? Because I was thinking you might want to do a sort of left outer join of that against your application logs or your audit. Do you see what I mean? Something bad happened in the app at 3:10, and I've got logs to show that from a poor performance. Can I then?
I'm trying to remember where you would find that. There should be DMVs to get to that information that you can pull that from. Basically, what's the number of connection requests that failed, or when did connection requests fail? I don't recall it from the top of my head what the DMV is for that.
All right, thanks.
Should we also consider the location of the DB when moving to the pool?
The location of the pool? Or?
The location of the database when moving to a pool. Like, for example, I have a database in Southeast Asia server, and then I also have a database in the US or US East.
So that's a great question, and
because I'm
right now
it's for the performance if I combine it.
Right now, that question is answered for you, and maybe not the best way, because you can only create a pool within a logical server, and a logical server lives within a region. So you currently cannot create a pool where parts of the databases are in Asia and other databases are in North America. That's not possible today. However, that's an ongoing discussion that we're going through, whether we want to make this available and what are the implications of it. And then, for instance, different performance characteristics, all of those are parts of the discussion that we are having on whether that makes sense or not. We don't know yet which way this will go. So
right now it's within the region?
Right now you're basically within a certain region, and you can only put databases from a single logical server that lives in a particular region. You can only put those into...
So it's grouped by server?
Yes, it's grouped by server. So you go and create a server. You actually see it here. This is the logical server. It lives in a well-defined location, central US. Those are all of the databases that are in that server. All of those databases are physically hosted and located in our central US data center as well. And only those databases you can bring into a pool. And that pool then also lives conceptually in that same logical server. So it's bound to central US as well.
And combining two databases from different servers in the same region is not possible right now?
Not right now. So you cannot stretch a pool across different servers either. That doesn't work either.
Okay. Yeah, another question for the PowerShell script.
Uh-huh.
Yeah, so I didn't see the delete DB from the pool. So is that available as
That
well?
works as well. So
Okay,
it's
so
just,
you have PowerShell script.
let me go back.
I think I only see the remove DB from the pool.
Yeah, and then, I mean, you can go in both ways. You can drop a database from a pool, or you can go through the steps of remove the database from the pool, and then it's just a regular database, and then call drop database on it.
But that is possible, deleting.
Yes,
the
yes, yes, yes,
direct.
yes, yes.
Okay, thank you.
Okay. Yes, please.
Not to improve, database size is limited in 50 gigabytes each database. But using it improve, database size limit is not difference whether using improve or not using improve.
Okay, let me make sure I understood your question. So your question is about database sizes.
Yes.
So individual databases can go to 250 gigabytes in standard or 500 gigabytes in premium. Now, what about individual database sizes in a pool? Is it the same? So the individual database sizes are limited in the same way. So if you create a standard pool, an individual database cannot be larger than 250 gigabytes. If at some point we have a premium pool, individual databases cannot get larger than 500 gigabytes. In addition to that, you also have an additional constraint or limitation, which is the overall storage amount that is allocated to the pool. And that may impose additional restrictions on your database sizes. So if you remember, the pool that I created only used 200 DTUs, and just as a function of that, it also became 200 gigabytes overall storage allocation. And that basically meant that an individual database, there's no way for an individual database in that pool to get larger than 200 gigabytes, because that's the overall storage amount that's available to the pool. If that is a problem, then I need to adjust the DTU allocation for the pool, and that will bring up the storage allocation for the pool as well. And then you can have databases go up to 250 gigabytes, but not many. Right? Did that answer your question?
Yes.
Cool. Any other questions? All right, thank you very much, and have a good rest of the conference.